Okay, here we go. Systems of equations, context, and yes, I do love math. I hope you're learning to kind of like it. All right, so example one, we've got a drummer, and that drummer's stocking up on drumsticks and brushes. The wood sticks that he buys are $8.50 a pair, and the brushes are $20 a pair. He ends up spending $148 on sticks and brushes, and he buys twice as many sticks as brushes. How many of each did he buy? Wow, that's a lot of information, right? And so what we're going to do is talk about the different information, the different types of information that they're giving us. First of all, we notice that we've got sticks and we've got brushes. For some reason, dealing with an S for a variable, sometimes it looks like a 5. We like dealing with X and Y. So we're first going to stop and say X is going to represent the number of sticks. Okay, so drumsticks, the number of sticks. And then Y will represent the number of pairs of brushes. So the pairs of brushes. So if Y is equal to 2, then we know we have 2 pairs of brushes. So that's the first thing we're going to do. Then we notice that they give us money, right? And they tell us that wood sticks are $8.50 a pair and brushes are $20 a pair. And altogether, he spends $148. Well, we've made equations like this before in earlier units. So let's see, wood sticks are X, and we know that for every wood stick, it's going to cost him $8.50. And he's going to buy some brushes, which we said Y stands for pairs of brushes. And I'm wondering why I'm saying pairs of brushes. I guess that's what I've decided it means. Anyways, so Y is the brushes are $20 a pair, and altogether he spends $148. But we need more than just this equation because this equation has 2 variables, right? It has an X and a Y, and we cannot solve an equation unless we're just down to 1 variable. So we need a second equation so we can solve it as a system. And so we're going to look for other information that they give us about these sticks and brushes. And I'm wondering why. I'm going to go back. I'm not sure why I do pairs of brushes. There's nothing in here that says pair. So let's say Y equals number of brushes. There we go. That makes it better. All right, so it's sticks and brushes. Now, they give us some more information, don't they? They tell us that he buys twice as many pairs of sticks as brushes. This is where our other information is going to come from. He buys twice as many sticks as brushes. All right, so let's say that it said he buys the same amount of sticks as brushes. Then we would say that X equals Y, right? But he doesn't say that. He says, or this says, that he buys twice as many sticks as brushes. So I want you to think about this. Which one does he buy more of? That's right, he buys more of the sticks. In fact, he buys twice as many sticks as brushes. So it's going to seem kind of counterintuitive, but we know we need to put a 2 in here somewhere. And believe it or not, we put it in front of the Y. Because what this equation says is that to make the brushes, Y, equal to the amount of sticks he buys, X, we have to multiply the brushes by 2, just to make the amount even. Think about it. If he bought 20 sticks, that's my X, then that means he would only have bought 10 brushes. So to make them equal, which is what we do when we put them in an equation, we would have to multiply the amount of brushes by 2. All right, so there are my 2 equations. And let's see what we're going to do. So what we're going to do is we are going to use substitution, and we're going to use it in a little bit different way than we've done before. So normally we like to solve for Y and then set, for both equations and then set them equal to each other. And we could do that this time, but I'm going to show you an easier route for this particular problem. Once again, we have a system, right? We have 2 equations, and we're going to use substitution. See how it says that X is equal to 2y, I'm going to go ahead and substitute in 2y whenever I see x in this first equation. So here we go. I'm going to write 8.5. I see an x. I'm going to say, nope, I'm going to write in 2y. There we go. Now we have one equation with one variable. So we're going to continue. We're going to say 850 times 2, that's 17, so that's 17y. Then we're going to add 17 plus 20, and that's 37. And then we're going to divide both sides by 37. So if you pick up your calculator, 148 divided by 37 is 4. So we know that he's buying 4 brushes. We can just stop here, right? Because what did it say? We can plug it in or we can think. It says he buys twice as many sticks as brushes. So if he bought 4 brushes, we know right away that means that he's going to buy twice as many, right, sticks. Now, let's say that we didn't want to use logic and we wanted to plug it in. Well, as soon as we know that y equals 4, we're going to take that information and plug it into the easiest equation. So x equals 2, and we're going to plug in 4 for y. So 2 times 4 is 8, x equals 8. So that's how we get our answer. So it's really important. See how I'm saying, yes, x equals 8, but then I say, hey, sticks. During context problems, you want to make sure that your answer matches with a word. So x equals 8 means he's buying 8 drumsticks, and y equals 4 means he's buying 4 brushes. So let's go back real quickly and talk about what was different about this problem. I think the first part, the green part in these sentences right here, this seems very familiar. What was it? When were we writing this? Maybe linear functions we were writing this. Looking at when they're giving us 2 prices and they total, we know that we can write the equation like that. The trickier part was the part in red. And so once again, you may, after this video, want to stop and come talk to me or one of the other teachers and talk about some different examples where you can practice the x equals 2y again, because I think that's the tricky part. And then the other new part that we did was, and normally when we use substitution, we like to solve for y with both equations, and then we set the other 2 sides equal to each other. This time, we use substitution differently. We saw that x is equal to 2y, and so we said in this first equation, when we see x, we're going to plug in 2y, since x equals 2y. And then we solve for y, and then use logic to find x. All right, so I would like for you to pause this before you move on to the next context problem, because each context problem is a little bit different. Kind of go over each step, pause the video, and then go ahead and move on to the next one. Once again, you're free to pause the video and flag one of the teachers over as you're learning this to ask questions. All right, so let's pause, reflect, and then move on. All right, welcome back. Example 2, a rectangular lot is to be fenced on 3 sides, and the owner's house borders the 4th side. Makes sense, right? That's how, if you live in a home where your backyard's fenced, your fence does not go up against the house, right? There's just 3 sides to your fence. The perimeter of the 3 sides is 70 feet. The owner is going to put up oak fencing along the 2 widths. That costs $20 per linear foot. And the owner is also going to put up lattice fencing along the back length. That costs $25 per linear foot. So instead of making it easy on us and just putting up the same fence along all 3 sides, the owner is going to do 2 different types of fence that cost 2 different amounts of money. And the total cost of fencing is $1,550. So once again, we're going to see something that looks very familiar because we've already done this in a different unit. And so what we're going to do is look at the money. And the first thing you want to say is, well, actually our drawing sets up that x are the sides and y is the length, right? X is the width and y is the length. So here we go. The owner's going to put up oak fencing along the 2 widths that costs $20 per linear foot. So here's what we're going to do. we know we have side x and another side x and another side that's y. Each of the x's, so along the two widths, costs $20 per linear foot. So we're going to have one of the sides, the width, is going to be 20 times x, the cost of it. And the other side's also going to be 20 times x. And then the length is going to be $25. So we have all three sides, and we know that altogether the owner is going to spend $1,550. All right, so that equation's pretty basic. Now we're going to want to simplify it, right? 20x plus 20x is 40x. So here is 40x plus 25y equal to $1,550. This is our first equation that we're going to use. But once again, we can't solve an equation when there are more than one variable, when there's more than one variable in it. So we need another equation, because if we have a system of two equations, then we can solve for two variables. So let's look for information that's going to give us the second equation. So look at the first sentence. It says rectangular lot is to be fenced on three sides. The perimeter of the three sides is 70 feet. This is where our second equation is going to come from. So the three sides, let's see, I've got x plus y, and if you add those together, which is what perimeter is, it's going to equal 70. We're going to make it look a little bit better. So we have x plus x is 2x plus y equals 70, and there we go. That's our second equation. So if we look at these two equations, the one in green and the one in blue with the arrows, we can think of a lot of different ways to solve each one, right? I could make a wish, let's see, with the second one and make the 2x be a 40x, right, by multiplying everybody by 20. I could make a wish and say, I wish that y right here, instead of a y, I wish it were a negative 25y, so then those would cancel out. I'm going to go with that route, but once again, you can make a wish on either the x or y, and you'll end up with the same answer. So I'm going to go ahead and multiply everybody in this equation. I'm going to multiply everybody by negative 25. So 2x times negative 25 is negative 50x. Negative 25 times y is negative 25y. And then 70 times negative 25 is negative 1,750. Now, I could have multiplied everybody by 25 and then subtracted. Same thing. So now what I'm going to do is I'm going to bring this original equation down right under it. So 40x plus 25y equals 1,550. And I'm going to go ahead and add. So I get the negative 50 plus 40x is negative 10x. And then, of course, we planned it. We made our wish so that these two canceled out. And then negative 1,750 plus 1,550 is negative 200. We're going to divide both sides by negative 10. And we get that x is equal to 20. So what does x stand for? X is the width. So we're going to put a little arrow and say the width. Now all we need to know is what is the length. So we're going to go back to the equation that gave me this equation. Let's see, 2x plus y equals 70, if we can find it in all our work. So we're going to find that. That's a perimeter equation. 2x plus y equals 70. And we know already that the width is 20. So we're going to plug 20 in for x. So 2 times 20 plus y equals 70. I'm going to go ahead and solve that. 2 times 20 is 40. Let's subtract both sides by 40, and we end up with the length being 30. So once again, I highly recommend you pause this, you look at all the steps that we did, you talk through it. If you're learning this at home, if you have any questions about this, maybe write the questions in the margin, so when you come back to class, you can ask us. And if you're in class, after you've paused and looked it over and you still have questions, come on over and ask questions. All right, so pause, reflect, and then move on. All right, in our last example, we've got workers at Wendy's can make, so I guess I'm using Wendy's and Burger Queen instead of Wendy's and Burger King. All right, workers at Wendy's can make 25 burgers an hour, while workers at Burger Queen can make 40 burgers an hour. If workers at Wendy's are paid $10 an hour and workers at Burger Queen are paid $18 an hour, how many workers from each restaurant were used at a catered event if 400 burgers were made in an hour and the cost was $170? All right, so there's some assuming here. We're assuming that there was a catered event and the people that catered it used both restaurants. So there's a lot of information, and the first thing we always focus on is money, right? Because we've done this before. We've made these equations that involve just money. So we're going to focus on the money first. All right, so let's go ahead and make X to be Wendy's workers. Once again, we could use W and we could use B, but for some reason we stick with X and Y. Y is Burger Queen's workers. All right, and so we're going to look at the amount of money that they're paid. So Wendy's are paid $10 an hour, and Wendy's, we're going to say X stands for Wendy's. So we know that any worker that works there gets $10 an hour. And at this catered event, there were also Burger Queen workers, and they were paid $18 an hour. I'd rather work at Burger Queen, wouldn't you? And that the people catering it are having to pay these people, right? It's not a very big event, though, because the cost is only $170. All right, so that's $170. The total goes there. So once again, we're pretty good at making these money equations because we've had practice with it. But we know that one equation with two variables isn't going to get us an answer. If we have two variables that are unknown, we need two equations to solve for those two variables. So we're going to look at the other information that they give us here. Workers at Wendy's can make 25 burgers an hour, while workers at Burger Queen can make 40 burgers an hour. And now we're looking for a total, right? 400 burgers were made in an hour. So we're going to go ahead and put that equation together. So the Wendy's burgers, they make 25 burgers. I'm going to talk quickly. The Burger Queen is 40, and all together they made 400 burgers. Okay, so what we're going to do is we are going to simplify we're going to simplify the first equation. I'm going to divide everybody in the first equation by 5. So here we go. Oops, no, I'm going to divide everybody from the first equation by 2. So I'm going to say I'm going to have 5x plus 9y equals 85. And I'm going to divide everybody in the second equation. Sorry, guys, my students are coming in. I'm finishing this up. Everybody in the second equation is going to get divided by 5. So we'll have 5x plus 8y equals 80. And now we notice that both the x's, I have a 5x here and a 5x here. I'm going to pull this equation down, and I'm going to go ahead and subtract. So I end up with 5x minus 5x is gone. 9y minus 8y is y. 85 minus 80 is 5. What does y stand for? Y stands for the number of Burger Queen workers. And then we plug that in to either equation. I'm going to plug it into, let's see, my 5x plus 9. I'm going to plug it into this equation. So I can plug it into either the original equation or the simplified equation. I'm going to have 5x plus 9. When I see y, I'm going to plug in 5 equals 85. So I have 5x plus 45 equals 85. I'm going to subtract 45 from both sides. So I have 5x equals 40. Divide both sides by 5, and I get that x equals 8. What does 8 stand for? number of Wendy's workers. All right, once again, pause that, go over the steps, and if you have any questions, ask me. Thanks for joining me. Please make sure you do lots of practice in this.